everyone, and welcome. It is Wednesday, and we are here for you, our Rockhound supporters on Patreon. Thank you so much. We really appreciate your generosity of helping us out with your monetary contribution of $25 a month. And we're doing it today for the first time with a white glove service. Yes. So that's making. I have a whole tray here of rocks that we are going. Whoa! Don't look. Easy, easy. We're gonna get through those. We're all gonna look through them. We're gonna put the pedal to the metal. We have a lot of stuff to get through. So Sue, you're gonna tell us about these things as we go. Correct?
That is correct.
Nice. We are ready for meteorite or meteor. Well, we're ready for meteorite, but meteor wrong number one.
All right. Well, this one came to us from JB, and she is a returning supporter. I believe this is her third Rock ID in the last few months. I think she went, we had her first last month as well. She had done such a great job with her video, so I decided to let JB go first again. So this one was found in Wyoming. Kind of in a high desert area, rocky terrain. It weighs, I think, close to 800 grams. She cut it in half and polished it. Looks pretty cool, actually. So she performed her test on camera. I think we may have some feedback about her streak test, but yeah, strong attraction to the magnet. It's I think between 2 and 3 minutes. We have a few pictures to look at too, and here are a few of the meteoritic features that JB believes that she was observing with her specimen. So we'll have to take a look at the pictures. Yeah, she thinks she has a stony meteorite. Wasn't really sure beyond that, but stony meteorite was her guess.
These are some of the pictures, and thank you very much, Sue. Sue has a new form that that the Rockhound supporters are filling in, so we can collect these data points and share them with you guys. And JB, good job again on the media. I will tell you, your first again. What does that tell you? Good job. And you actually named all your photos like Sue asked, so we know that this one shows the metal blebs and flow lines that you're seeing.
I get so excited when someone actually follows my directions. JB has been so great about it. We always want to know what meteoritic features you guys think you're seeing, so we can either, we can see it from your perspective, and if you're not really seeing what you think you're seeing, we can at least help guide you.
All right. I'm going to allow people to enjoy this for a second and then raise their hands when you have some feedback to share with us.
And she does her testing pretty quickly here in the video. My one bit of advice was I thought maybe press a little bit harder next time on the
Yeah.
porcelain.
What we're really trying to do is get a hard rock to rub off on something. So we're really going to use a lot of elbow grease and a lot of pressure on it. And I actually have a tile here that I'll be doing the white glove service scratch tests on for some people. This is unique with the center core. All right. Does anyone have any? I'm looking at it. I'm seeing a lot of like brecciation in there. Maybe fibrous. Okay, we have one hand up. I'm going to go to you in a minute, David. What I'm seeing on the outside, I'd like to comment that I don't think it's fusion crust. It's a little too red. I don't want to steal anything from you, so go for it.
Yeah, the fusion crust, it looks more like a weathering rind. I've seen this before on some of these, and this looks very similar. Don't see flow lines, very rough texture, and if it's a fusion crusts don't have those little vesicles and rough texture, unless they're rare instances. The interior, I don't see chondrules. And if there's metal blebs, I don't generally see metal blebs with an achondrite. So I don't know what kind of rock it is, but that's what I got.
Awesome. Thank you very much. I'm going to go to Art. Art, I hope you can keep it brief, and I hope you were going to talk about what the structure looks like to you, because I know you know a lot about geology and rocks.
To me, it looks porphyritic, like volcanic, because I'm seeing in the outer uh, brine vesicles, and on the inside, definitely uh, going on. It looks like something was encapsulated
Mm-hmm.
in the center there, which would lead me to believe in the flow, the volcanic eruption, the lava engulfed that, and then the whole thing solidified. But I would look at it as being porphyritic volcanic origin.
I thank you very much, sir.
You're welcome.
Patrick? Pat,
There we go.
are
Sorry.
you-
Yeah. So same thing the other guy saw. No chondrules. The white flecks in the black matrix looks very igneous. Many igneous rocks on planet Earth will attract a magnet. Possible olivine bomb in the middle, maybe, but definitely not a meteorite.
Pat,
And the
can I interrupt you for 1 second? You said
yes,
possibly an olivine bomb in the center, but I noticed when the magnet swings over, it attracts right to that center.
yeah,
Think
and
so, or
it
is that
the
just
olivine is wouldn't be pure olivine. It would have other stuff in it, so there's likely magnetite and other iron ore sort of minerals in there. uh,
okay?
and the surface is not fusion crust. In order to have flow lines, you have to have fusion crust first, and that is a weathering rind. It's the wrong color. It's too thick.
Yeah, yeah. The
That's what I
weathering rind can't exist basically with fusion crust. It's either or, and the fusion crust would be replaced and fall off, and then the stone would get a weathering rind to it, if that's what you're alluding to. I said three people, but this guy probably has something to say about the texture. So, Boris, what do you have for us, my man?
One quick comment. If you
Yeah,
look at some of the let's say the orientation of those white flecks, there does seem
yeah.
to be seem to be some orientation or some linearity to them. So that would support potentially at some point there was a direction or a flow or some type of textural um, directional indicator, perhaps pressure. But there does seem to be some flatness and some orientation to those little white flecks, and they do actually go right through the center. If you take a look, it may be a difference of color between the outer and the inner, but those little flecks do seem to go through to some degree.
Do you think that the reason they're not so evident in the center is because of weathering,
Uh,
or
I'm not sure. I mean, there could be a number of
okay?
effects, to impact that. It could be anything from compositional to, to heat distribution or relation, dissipation.
And
But
and
they're
you're talking about terrestrial heat, volcanic heat, something like
volcanic.
that.
Yes,
Yeah.
exactly.
All right. Thank you very much. I really appreciate that. I think the crew kind of nailed it. We love being able to say what we think it is, but a lot of times we're not able to really narrow it down because we don't have it here, and we're not, some of us are geologists, but we're not geologists, and that's not really the goal. I think the entire crew here, and maybe I'll throw it to you in a second, Sue. I think the entire crew here is in agreement that we're not seeing. We see some interesting features. We all see what you're seeing, but we don't think it's a meteorite because of the reasons we pointed out. No chondrules, no visible metal flakes, a weathering rind, and not fusion crust. Sue, did you have anything else?
I just wanted to add, I was researching this online while people were talking, and is it possible it could be an iron oxide concretion? It's described just the way that it looks, and it says that people mistake it for meteorites quite often. Um, and yeah, black circular, formation in the middle of it with the grayish and the white matrix around it. So just wanted
That's
to add
all.
that.
Well, thank you very much, Sue. That helps out. So there's something you could look for, possible identification. We are on to number two, and I ask you, who does number 2 work for?
I knew that was coming.
Okay, Sue, can you tell us about this submission from Sergey? Or is
Yes,
it
so
Serge?
I believe that it's Sergey. He is from Vienna, Austria. So that is just my guess. Sergey, um,
I'm going to say Serge. I think Serge would be German.
you should know better than I do. Your mom was
Yeah.
from Austria.
Yeah, my mom was born in Austria, so I think it's Serge. But either
Okay.
way, we apologize if we're saying it incorrectly.
All right. Well, Serge found this rock in an open forest area. He described it as a tiny river. I kind of added creek to that. But yes, he found this rock in the water. He doesn't know how long it was in there. He guessed that maybe someone threw it in there and it maybe was not in there for too long of a time, but long enough that it grew some or it had some grass growth on it. But yeah, it's almost 3 kilograms. And we have yeah, so he did give us the results of his testing, but he did not, I don't believe he performed these tests on camera. We always ask that we love to kind of see how people run these tests. Not so much the magnet one, but definitely the streak test, because you can do things that get better results with the streak testing. So Serge believes that he viewed some
Oops, I
regmaglyphs.
apologize.
Oh, that's okay. And he felt that one side had like the grass on it, and then the other side he said looked burned. I kind of had a hard time trying to see which side looked burned. I didn't think that one side looked burned, but there is one side that's a little bit darker. And then he did see, he saw a spherical shape within the other side. I had a hard time locating that as well. But then he also mentioned he cut a window into it, and I do believe I found that. I think that one was pretty obvious. So I did include some notes on the photos that Sergey sent me, but they're not necessarily matched up to the photos. I just wanted to, he gave me a lot of information. I wanted to fit it in where I could. So, and as you can see, he believed that he found a Howardites melt breccia.
Okay. I'm seeing some. Well, I just edited last night Stephen Amira and Pat Brown's submission that has 3D chondrule sticking out. So I'd love to get Stephen Amira or Pat to comment on those because that's what the Rockhound could be seeing on this. But a Howardite, 3D chondrules.
That's the window, I believe.
There's a lot going on in there.
Yeah, those are some pretty big holes, natural holes or vesicles.
Those are holes. Those are voids.
I think
What?
so.
This one right here, maybe. And
Yeah, when you get
okay,
the bigger view, I think it looks more obvious.
okay. Looks like Gujba. Sorry, guys. Um, it's weird seeing the color being tan, reddish, and white. Hopefully, someone will have some feedback on that. Wow, it's a big one.
Yeah, that's why I said you'd have a better idea of maybe figuring out these
Yeah,
features of seeing the
yeah.
whole stone.
Wow, there is a lot in there. Allison, what are you seeing right off the bat? I know we just started the video.
The the holes look more like vesicles to me than they do like regmaglyphs. I I do see, spherical inclusions and stuff, but that's really common in earth rocks in breccias and conglomerates on Earth. So it's a combination of like vesicles and like breccial breakup that I think are causing these regmaglyph shaped, imprints in this rock. I don't see anything burned or fusion crust looking. Um, and I'm not entirely convinced that that's a flight oriented shape. So that
If
just kind of touching up on what he thought he saw there is what I see.
Awesome. Thank you very much. I really appreciate it. We're going to turn it to, I think Chris Monk. Does Chris Monk have his hand up? I think so. We're going to go to Chris Monk in 1 second. I look at this little patch right here, and again, I'm seeing it from the Rockhounders' point of view. I'm always going to try to argue their point of view. That looks like the marshmallow fusion crust you guys always go crazy over. Chris, do you have a comment on that or anything else? So to me, this looks very sedimentary. There's a lot of terrestrial sedimentary rocks. There are very few sedimentary meteorites. Maybe Ishievo being one of them, they think might be sedimentary, but this, I mean, to me, sedimentary looks like concrete. You cut a piece of concrete, you have spherical river rocks in it, you have some sort of matrix holding it all together. This looks very sedimentary to me. Um, yeah, that's all I got. Okay, thank you, man. I appreciate your feedback. Wow, we have so many hands up right now. I am going to go with Stephen Amera because I asked for your feedback.
Yeah. So my immediate thought on this stone is that it looks a lot like pudding stone, and those 3D inclusions in there. Uh, it's something almost on the lines of sedimentary, like Chris is saying. It's been picked up other little stones along the way, and then those indentations remind me a lot of river stones, where sand tumbles within those indentations from the flow of the water and carves out those little regions in the stone. So I'm in support of what everybody else is saying, and in agreement that this is terrestrial.
All right. Thank you, 3D chondral expert. Last
You're
on
welcome.
this one was going to be Allison, and she put her hand down. We will give her the last right of refusal. Do you have any feedback for us?
It was still up from earlier, but yeah, the color of the inclusions in and the distribution of them just don't, to me, line up with what we see in chondrites.
Yeah. All right. Thank you. I appreciate that. We're going to have a little bit of, I agree with what everyone's saying. We're going to have a little bit of lesson on Howardites in a little bit. And one thing you'll learn is, I don't want to ruin the surprise, everyone, but Howardites are achondrites. So achondrites do not have chondrules. So this cannot be a Howardite if those are chondrules. So it's not a Howardite. Well, let's look at it and go, okay, well, those are those chondrules now. Well, I kind of agree with everyone saying there's a mishmash of everything, a conglomerate of a bunch of terrestrial materials inside this one rock. And then it's been tumbled for a little bit. But yeah, I'm literally seeing in a lot of different type of earth rocks all put together, and that's not usually what we see in a meteorite. When we do see a meteorite that has different classifications all put together, it brings to mind like the Almahata, which was like, we call it a rubble pile, but like each stone was classified differently, not all shoved together, still with different classifications of meteorites all in one. So I agree with the crew, and I thank you for your submission on this one. Last person, Sue, what do you got for us?
The one thing that Serge mentioned that I did that didn't make it onto the slides was that this rock looked a lot different than all the other rocks that surrounded it, and he thought that it was really dense and heavy for its size. I know we can't measure the density without having it physically in our hands, but is what do you think about the size, Topher? Do you think that looks like a 2,800 gram? It feels really big. Like it feels like it's.
It looks big for, I mean, if that was a meteorite, I would expect that to be well over 3 kilos. It looks like a 5 kilo stone, to be honest.
Yeah, that's what I was
Maybe
thinking. So
7
that's the
kilos.
only, yeah, that's the only
Yeah.
other thing I want to mention. It does not seem like it's dense enough to be a meteorite.
Yeah. Wow. Great observation. Thank you so much. Glad I came to you. And we are moving on to the next one, which is our first white glove service. So this is going to be exciting. I'm going to show these off.
Because
Thank
it's
you,
something
Danny.
that people have been asking us about quite a bit.
Yeah. We wanted to just talk a little bit more about this white glove service, and because a lot of people have been talking and asking about it, and which is great. We actually have some submissions we're doing right now. But Sue wanted to bring out a little bit of the benefits and restrictions of this. So I can turn it right over to you, baby.
Okay, yeah. I mean, as you can see up on the screen already, a lot of our rock hunters are I'd say very people that are out in nature and they really, really don't want to deal with technology. We have a lot of people that struggle with uploading their media. They're trying to all different ways, and they get frustrated. And can I just ship it in the mail to you? So, this is a high demand. A lot of people asked for this, and yes, it does cost a little bit more, but now you don't have to worry about doing any of the testing. You don't have to magnet test, streak test, nickel test, all that stuff. You don't have to worry about any of it. You don't have to take photos, take videos. You don't have to have me sending it back to you saying it's the wrong format. It's really blurry. You're not holding it right. Like all of that is just not even a concern anymore. And so we're asking very little of you. I streamline the process instead of emailing back and forth and asking over and over, how many grams does it weigh? There's a survey, you fill it out. It's 10 questions. It's super easy. I actually can see the times it takes people to fill it out, and they're really quick. So yeah, and we were going to handle the window into the rock, but not every rock requires a window or to be cut. But if you would like that to be done, to just take that extra step, we are requiring our supporters to do that on their own before they ship it to us. And then the only other thing you're responsible for is issuing a return label. Most people don't need the rock returned once they, if they find out it's a meteor wrong, but some people still want to get it back. So as long as you issue that label to us, we'll get it back in the mail within, a week or two, probably.
Yeah, thank you very much. And one of the benefits of this, obviously, is if it is a very beautiful but terrestrial rock and you want to get it back to make more slices, you don't want me just getting and hunking it down the middle. Like, I don't want to ruin your rock. So, and I honestly don't have time to cut a bunch of rocks. So if you prep it ahead of time, that's how I'm going to show it off. If it's sliced, if it's windowed and polished, that's awesome, and it is going to show and tell us a lot more. So I'd always encourage the rock hounder to do that. If you have faith in your sample, cut into it, let us see the interior.
And I think we're honest. The crew is honest enough that if you don't make a window and we are stumped, we'll let you know. But most of the time, we can make the ID. So yeah, like I said, here are all the things that we handle. All the media, the creation, editing, uploading, the different diagnostic tests, the return shipment once the label's issued to us, and also for, I guess not for a limited time, but we have a lot of people that, and we really appreciate it, that have signed up as rock hounders and have spent a year supporting us and then never sent a rock in for a rock ID. So they have like 12, 13, 14, unused rock IDs. So we are allowing people to trade 2 of those in for a white glove. So 2 of your $25 rock IDs that have just piled up on you, we'll send the rock to us, and we'll do 1 white glove per 2 Rockhound Hunter Supporter IDs.
Thank you very much, Sue. I appreciate that. And now we're going into number 3. Sue, can you tell us about submission number 3?
Sure, it's going to be pretty brief because most of the information we're finding out about this rock, you're going to be doing on your own right now. So this one is from George. He is a.
I think that's actually pronounced Jorge.
No, this one's George.
Sorry, I'm sorry, babe.
Oh gosh. Yeah, so George is a returning supporter. I believe this is his 3rd Rock ID. Yeah, I think one was quite a while, like sometime last year, and then one was a few months ago. George found this in central Colorado. Yep, along the high bank of the Arkansas River. This weighs almost 250 grams. And yeah, so we're gonna do the testing for him. This is what he believes he saw, chondrules, and I'm not exactly sure what this terminology means. Maybe one of you guys can tell me, but clasp pieces of diagonite. And this was really really random that 2 different rock hounders believe that they found Howardites. Like they are not related to each other, talk to each other, and I was like, that's never really happened before.
All right, so here we go. This is Jorge's or George's, however you want to say it.
Well, why don't you do the testing first? Show us how magnetic it is.
I am so glad I have a worthy helper, assistant, manager.
You're just so happy that
Yeah.
I'm into meteorites now.
I forced you. This no magnetic attraction whatsoever. Wow.
See,
Not
we need to know. We need to know that.
not on anything. Now, here is a piece of porcelain or ceramic.
Porcelain unglazed on one
This is
side, right?
unglazed, and I'm going to really give it a what? It is straight clean. Just absolute brown or white. So I'm going to say the streak test was performed, and it is a soft rock because that should not really have that much gone. I see a lot of different inclusions and a lot of white and a lot of black stuff.
Yeah, I like that you got some elbow grease in there. I was watching JB do her streak test earlier, and she was very delicate. You really have to really grind it sometimes. And we were talking about last time, sometimes you have to actually get your eye loop out and look. Sometimes the streak isn't always obvious, but it can be there. Like kind of you didn't really see it too much, but when you wiped it, you saw it. So I saw Allison's hand up for a moment. Allison, but now it's down. Did you have any thoughts that you wanted to share about this?
Yeah, I hesitated because I'm really not a Howardite or a diagonite expert. It's just not my strong point. But when Topher scratched that on the tile, it indicated to me that this is a really silicate rich rock. And that just reaffirmed to me that this is my opinion is that this is probably a terrestrial stone. There are a lot of vesicles and things are not quite distributed throughout the rock in the way that I would expect to see them if it were a Howardite or a diagonite. It looks to me more like an earth conglomerate.
Thank you very much. I appreciate that.
Pat, I see your hand up.
Yeah, so I think this one's going to be an earth rock. It does have clasts in it, and so it probably is a breccia or shows some breccia-like behavior. The big black crystals in it, though, make me want to say this looks kind of igneous.
Igneous means volcanic?
Volcanic, yeah.
Thank you very much.
Yeah, Bruce has in the chat, and yes, Bruce, I spoke to him about this already.
Oh my
Wear your
God.
white gloves.
She tried to get me to wear white gloves, but I'll be honest with you. I have for decades I've had the problem of picking on my fingers, but I conquered that, and I'm not wearing gloves. Those are beautiful, and they will be shown off.
He thinks he could be a hand model.
I
For those
can.
of you who have seen Zoolander.
Nice. Thank you very much. Can we have one more comment on this one, please?
Chris Sanders says this is fake advertising. Like those yellow spots. I wonder if that's what he was thinking was diagonite. Yeah, we have several people with their hands up. I'm gonna pick on Steven.
I'm sorry if I missed this detail, but has this stone been ground down on all sides and kind of rounded off?
No, it seems to be all natural like this.
Oh, okay.
But it's rounded.
I don't know. To me, it just looks like strangely, like kind of almost like several
buffed.
flat sides on it.
Yeah.
But my chief complaint about it is there's zero fusion crust on it, and for it to like look so fresh within the matrix and everything like that. If it had been exposed to the elements on Earth for so long, and it was a meteorite, I'd expect to see more weather staining if it completely ablated the crust away. But I think this one's terrestrial. I think you'd find some type of fusion crust on it, no matter what.
Thank you very much. I am going to agree with everyone on the crew. It's nice to see class, and like normally we would see that and go, "Wow, that's a big chondrule," but it's just not. You can see literally, I have powder on my fingers still. It's a very soft rock compared to a meteorite that has 12%, 15% nickel iron in it. It doesn't have any iron in it, and that's why it doesn't have any metals in it, basically, and that's why it's so soft and not attracted to a magnet. So this is a terrestrial sample, and it's interesting and it's beautiful. It could probably make some great slices because it is soft, but that is not a meteorite. All right, we are going to take a break from looking at these samples right now and get in with Professor Pat. We had two of our rock hounders today talk about Howardites. Pat was just going to give us a little bit of education on Howardites and just a little check-in to see if we can make every show a learning experience.
Yeah, so Howardites are achondrites, no chondrules, and we believe that they are from the body 4 Vesta, which is a very large asteroid. It is the only remaining protoplanet, and so it's been as it was for quite a long time. For some huge impacts 1 or 2 billion years ago, and that has provided us with some rocks from 4 Vesta. So there's Howardites, and I'll circle back to that in just a second. There are eucrites, which are igneous rocks that are essentially lava extruded out onto the surface. And some of those come with trapped gas from the lava, and that's why we see vesicles in some of the eucrites that we found. And diogenites are also from Vesta, and they're deeper. They're kind of the bottom edge of the crust, first part of the mantle, so deeper rocks. Now, the reason I mention those is we come now back to Howardites. Howardites are from the surface of 4 Vesta. And because this body has no atmosphere, and it's reasonably large, it's 525 kilometers in diameter, about 320 miles in diameter, but it's got no atmosphere. So anything that hits it at orbital velocity. So the surface of this thing has been pummeled with small, even micrometeorites hit at orbital velocity. And so it's like our moon, it's the surface of it is pulverized. And when another meteorite hits the surface, freezes or compresses that material together into a rock and then ejects it, it lands on Earth, then we have a Howardite. So Howardites are surface material. They are composed mostly of mix-up bits and pieces of the eucritic material, the eucrite material, and the diagenite material. And they are, as Sue has noted here, they're largely pyroxene and sodium poor plagioclase. And so we have to remember that all of the solid bodies in our solar system are made out of the same starting material. So meteorites from 4 Vesta, these Howardites, eucrites, and diogenites, are oftentimes difficult to distinguish from Earth rocks. And so we rely more on looking for regoliths, looking for fusion crust, etc., for the superficial identification of them. And that's what I had, Toper.
I appreciate that. Yeah, I appreciate you running through it at lightning speed. I wanted to have a tiny discussion because I think it's important for people to realize because you said it, but I'll say it in different words. The 4 Vesta or Vesta 4 asteroid is one that we sent the Dawn spacecraft to and actually tested and sampled, so we know what it is. So we know for a fact that these meteorites come from that type, that class, or even that exact asteroid. We are not 100% sure that all HEDs, Howardites, eucrites, diogenites, all come from that exact asteroid 4 Vesta. There are a lot of asteroids it could come from, but it would be from the Vestin family. So that's the signature. You hear HEDs and Vestin, and those go together, but not necessarily from that one source rock. And I thought it was very interesting you were talking about the depths of how far they go down, and that really affects what material is in there. So thank you very much. We have a few pictures of some Howardites that we can look at, and while we're looking at these, let's do Rock ID in reverse. These are meteorites. Tell me what you guys see. A hush falls over the crowd.
Yeah, so we see obvious fusion crust first.
And Dave?
I'd mentioned contraction cracks on the fusion crust. Yeah, there was some of that, and it's not necessarily you have to have fusion crust around the whole thing, because it does flail off either incoming or as it's weathering. And then here you see the interior, and you see different class that are a mixture of the eucrite and diagonite material from the surface.
Thank you, sir.
Mm-hmm.
And when you look at this one, you can definitely see if we're hiding the fusion crust from you and we say, wow, it looks really similar to the other one. Well, yeah, they do. As Pat said, they started out with the same materials. It's an achondrite, so it went through differentiation, and therefore it went through volcanic, magmatic, igneous processes, same as Earth did, and that's why they resemble each other and are hard to tell apart. So we look for sexy black fusion crust, just like this, to really give it away that this is a Howardite, or a meteorite at least. Now, these are the internal class inside of it. How can we compare and contrast this to what we noticed today in some terrestrial samples? Pat, you've been talking too much. By the way, I will say this: I give Pat a hard time every week in, week out. He's my redheaded stepchild. No, but more comments on a YouTube channel are about Pat. It's not his channel. He has nothing to do with this. He just shows up. But more comments are about Pat and about Pat's calming voice, and I can listen to him explain things over and over again. So, Pat, you bring that to the table, and you've also learned to change with us as we change with the times. A 10-minute pontification is not as valuable as a 1-minute spear chuck. So, thank you.
Hope, you know those videos that we watch sometimes at nighttime where people are explaining things, but it's like 10 hours of science to make you fall asleep.
Yeah.
Pat should record those audiobooks.
Oh, I'm gonna put one of those ASMR mics in front of Pat and ask him, how do chondrules form? Right, the chondrules that surround us. Allison, what do you have for us? What are you seeing in any of these?
Want to comment that we do not see a lot of the vesicles and pores and things that we've seen in some of the other samples presented to us today. It's kind of a beautifully chaotic distribution there that, you know, when those clasts are forming in space, they're in 0G, and it does something to the shape visually that we don't get in Earth rocks.
Thank you very much. I appreciate that. And I'm going to go to my favorite Howardite in my collection. This is mine. It is NWA 14638. It's not my classification, but look at that thing from the outside. It is just as beautiful on the inside. And someone who matches that identically is Art Wagner. Art, what do you have to say, buddy? Welcome.
In looking at the class, I noticed that there were angular as well as sub-rounded class, but the class seemed to have other smaller bits of class in the fragments. So
yes,
something that I normally see a lot in earth rocks. If you see a class in an earth rock, it's going to pretty much be 100%. The whole thing is the same type of class. You won't see a lot of fragments, and you know, that's something that's pretty common in meteorites, and especially the Howardites, I guess. So yeah, and the colors too, you know, of the inside of the Howardite, you know, much different from the outside. So yeah.
I think you hit a home run there when you said class within class. That's
Mm-hmm.
something that's super important because we're seeing in basically all of these samples. You can see up there on the top, like this has class in it, this has in it, this does down here, like
Mm-hmm.
everything. Yeah, so that's a great observation. Thank you very much.
We have a hand up from our on-staff geologist, Mike Kelly.
Oh, awesome. I didn't know who iPhone was, and I wasn't about to give him any time.
That's
Go
why I
for
wanted to point
buddy.
it out to you.
Thanks. Appreciate it.
Hey, good evening, everyone. So one thing you're noticing in all the samples you're showing is the clasts that are in there are sub-round. They're not overly angular and they're not overly round, right? So you would have angular clasts that are very unaltered. You get that a lot in earth rocks, volcanic earth rocks, because they've only been processed once and still very coarse. On the other end, on those like samples we saw that were probably conglomerates, they're overly rounded, right? They've been washed too much in a fluvial environment. And when you look in meteorites, you see a lot of clasts that are sub-round, so they have some rounding going on, and that's a lot to do with multiple impacts and them being melted several times, or partially melted. But you're never really going to get to a water-round smoothness with like a perfectly oval type shape in the clasts themselves. And the other thing you're noticing in all of those specimens is you could see the orthopyroxene, right? The greenish crystals in there.
Mm-hmm.
Whereas if you looked at the rock that looked like it was a pyroclastic MeteorWRONG, right? It was basically all andesitic looking. There wasn't very much change in the colors. You didn't get any of those greens of what would be basically diagenetic material, orthopyroxene. Um, so again, if you're leaning towards Howardites, you should kind of see that green, even if it's fine in the matrix, like the shot you just had up. You could pick out the orthopyroxene, which has to be at least 10% in the kind of greenish staining within the gray. If you look at the very, very small bits, like down towards the bottom where that black class is, you can see the kind of greenish tint to it.
Yeah.
So that's what I wanted to point out.
Fantastic. I really appreciate you drawing attention to getting out an eye loop and looking at the sample up close and looking for those different colors. This one is obviously when you find something that has fusion crust on it like this, you obviously know it's a meteorite, but the HEDs are known for having really glossy black fusion crust. And this is Serge from Turkey. Thank you guys so much for watching. I really appreciate you joining us week in and week out as we try to educate ourselves and everyone else on what a meteorite really looks like and what a really cool earth rock looks like. So thanks a lot, all you Patreons. We really appreciate it. If you don't know the magic you're missing on Patreon, download the app, become a free member. You can watch us on your phone. You can listen to us while you're working, and yeah, get with it. All right. Good night, guys. See you next week.